This is the world we recognize, a stable blue planet that easily sustains 8 billion people. Because it has looked this way for all of human history, it's easy to assume this state is permanent. But 4.54 billion years ago, there were no oceans, no oxygen, and no life. Earth was a sphere of boiling magma under constant asteroid bombardment. The journey from that cooling rock to modern civilization wasn't an inevitable progression. It was a 12-chapter chain reaction where every geological shift and biological mutation had to occur in a precise, unbroken sequence. This timeline is incredibly fragile. If we remove even one of these major thresholds, a specific asteroid impact or a single bacterial evolution, the chain breaks and humans never exist. To understand our place in the world today, we have to look at the specific physical and biological turning points that made our existence possible. Everything began 6.6 billion years ago with the solar nebula. Gravity pulled this massive cloud of gas and dust inward. Most of it formed the sun, while the remaining debris collided repeatedly to form the planets. Because the young Earth was entirely molten, it underwent planetary differentiation. Heavy metals like iron and nickel sank to the center to form the core, while lighter materials stayed on the surface to become the mantle and crust. As the crust cooled, volcanoes released massive amounts of water vapor and gas. This vapor eventually condensed into clouds, and rain fell for millions of years until it filled the very first oceans. This physical cooling was the first essential prerequisite for our story. It provided the liquid water necessary to cradle the chemical reactions that would eventually become life. In those early oceans, around 3.8 billion years ago, the first simple, single-celled organisms appeared. For nearly 2 billion years, Earth was inhabited only by microscopic life, incapable of forming complex structures. That changed 2.4 billion years ago when bacteria evolved photosynthesis. They used sunlight to create food and released oxygen as a byproduct. This great oxidation event was a dual-edged sword. While it caused a mass extinction for organisms that couldn't tolerate oxygen, it also formed a protective ozone layer in the upper atmosphere. By permanently altering the planet's chemistry, these bacteria built the biological foundation required for complex, multicellular life to survive. Around 541 million years ago, the biological record suddenly diversified in an event called the Cambrian explosion. Almost every major animal body plan appeared during this window, including complex arthropods like this trilobite. As plants established a foothold on land, they transformed barren rock into habitable ecosystems. This migration allowed insects, amphibians, and reptiles to leave the oceans behind. These new land-based habitats allowed dinosaurs to become the dominant force on the planet. For 186 million years, they occupied nearly every major ecological niche on Earth. That dominance ended 66 million years ago when a massive asteroid struck Earth, wiping out the non-avian dinosaurs and thousands of other species. This impact served as a necessary reset. By removing the planet's apex predators, it created an ecological vacuum that allowed entirely new classes of animals to diversify. Mammals, which had been minor players for millions of years, stepped into this void. They rapidly adapted to new environments, eventually branching into the early primate lineage. Over 7 million years, this lineage evolved from early hominins into Homo sapiens. By 300,000 years ago, modern humans had finally appeared. Humans began to bypass the slow pace of biological evolution through technology. By developing language and agriculture, we gained the ability to consciously shape the land to meet our needs. This agricultural stability led directly to the growth of cities, the pursuit of complex science, and the development of the modern world we see today. Human intelligence and society are the direct end products of that biological vacuum left 66 million years ago. This chain reaction hasn't stopped. As this buckled road shows, the planet remains a highly active geological entity. Plate tectonics are still moving the continents, and the climate continues its natural long-term fluctuations. However, we have entered a new phase. From our impact on the global climate to the creation of advanced digital networks, human activity has become a force of change that rivals the geological processes of the past. For 4.6 billion years, Earth's story was written by accidental collisions and blind evolution. Today, for the first time in that history, the planet's future trajectory is being determined by the actions of a single species.